everyone, today we're looking at note C-1, tangent lines, day 1. Make sure you have your straight edge readily available because we'll be using it a lot today. So the directions state to show all work that leads to your answer. Okay, that includes the drawings. Okay, so make sure everything I include, everything it asks for on the drawing, make sure that you provide it as well, not only on the notes but also on your assignment. So let's get started. So number 1, O is the center of the circle, defined by x squared plus y squared equals 20. Okay, so recall from geometry that when you have the equation of a circle, this number here is the radius squared. So if we square root this number, that'll tell us the radius. Okay, so what's the square root of 20? Do you know it without a calculator? Probably not, so then just use what you do know. You do know the square root of 25 is 5. You do know that the square root of 16 is 4. Why did I choose those two numbers? Well, because 20 lies between 16 and 25. So therefore, the square root of 20 lies somewhere between 4 and 5. So we're just going to estimate it's about 4.5. So our radius, remember the radius is the distance from the center to any of the endpoints on the circumference. So our radius is about 4.5, okay, for this circle. Then it says let P be the point in the second quadrant. Remember quadrant 1, 2, 3, 4. So let P be the point in the second quadrant where x equals -2. Well, if I know that the radius here is about 4.5, then half of that is 2.25. So that's about 2.25. So if I just want -2, then that might be about right there, I'd say. Right, so remember we wanted P to be the point in the second quadrant, so we knew this quadrant where x equals -2, and you saw how we found about where x equals -2 was, because the radius is 4.5, half of 4.5 is 2.25, so we didn't quite go halfway. Okay, so we're going to label this point P, and I am going to put some space, and you'll see why here in a minute. Okay, so point P, because in part A we want to determine the coordinates of P, meaning the x and the y coordinates, okay? Well, that part of that is easy. Okay, the x coordinate is -2. We already know that. All right, so I'll go ahead and write it over here too. How do we find the y coordinate? Well, you're given this wonderful equation here, aren't we? So if I come over here, I'm going to write this over here. I plug in -2 where I see x plus y squared equals 20. Right, -2 squared is 4, so 4 plus y squared equals 20. So if I subtract 4 from both sides, I get y squared equals 16. Good thing, that's nice. I'm going to rewrite that line. I want you to as well, so we can show the next step is square rooting. Okay, obviously, the square root of y squared is absolute value of y, and the square root of 16 is 4. Therefore, y equals plus or minus 4. Well, which one do I choose? Which one do I choose? That's easy. Just look. Look at our picture. Okay, is our y coordinate here or our y value here +4 or -4? Of course it's +4. Okay, sometimes a picture is worth 1,000 words. Okay, here's our straight edge part. Draw OP. So do your best job at drawing OP. There we go. That's all right. Okay, so determine the slope of OP. How do we do that? Remember, slope is change in y over change in x. And if this is the origin here, the center is our origin, we know that's 0, 0, so then we can find out the change in y over change in x. So how much did we rise? What was our change in y? It was 4. And then we went, so we rose 4 and we went left 2. So remember, left is that negative movement, hence the -2. Okay? So therefore simplify and you just get -2. So whenever you come over here and you list your answer, make sure you include those labels. So change in y over change in x equals -2. Okay, draw the tangent line at point P. Well, what is a tangent line? And today we're going to talk about the tangent line of a circle only. We will get to tangent lines of other graphs, but the definition of a tangent line of a circle is it's a line that touches the graph at a single point and a tangent line is perpendicular to the radius at that point. Okay, so if we want a tangent line at point P, right, at point P here, we know we want a line that touches the circle at only one point and is perpendicular to the radius at this point. So the radius at this point is drawn as follows. You have it here. So you know that a line perpendicular to this line would have a 90-degree angle here. So we know it would look something maybe like that. I'm trying to, with my human eye, I'm trying to do my best job. And think about this. Does that line touch the circle at one point? Well, of course I'm human, so it kind of looks like it touches more. But what I'm saying is, like, if I would have drawn the line like this, then it would have cut through the circle at two places, and that's not allowed. It basically just lies on top. So think of the circle, and that line literally lies on top, just touches at that one little bitty point there. Okay? Now that's for a circle. Remember, when we get to other graphs, it won't necessarily be that way where it just touches at one little point. You'll see. But for a circle, the tangent line touches the graph at a single point and is perpendicular to the radius at that point. And that's what we have. Okay, so we've drawn the tangent line. All right, now determine the slope of the line tangent to the circle at point P. So we want to know the slope of the line tangent to the circle at point B. So essentially we want to know the slope of this line. Well, first let's talk about, we said what the slope of OP was, but we didn't write it. I want to go back in and write it. So the slope here was -2. Let's pause for a moment. Does that slope make sense for this line, -2? I hope so, because from left to right, that line is certainly falling. So a negative slope there makes sense. Of course, what kind of slope should this be? Two reasons why you should know that this line is going to have a positive slope. Reason number one, because from left to right, this graph is climbing, but also because, remember, these two lines are perpendicular. What do you know about perpendicular lines, about their slopes? Oh yeah, they're opposite reciprocals. So the slope of this line, since it's perpendicular to this line, is going to be positive 1/2. Take the opposite reciprocal of -2. So change in y over change in x of my tangent line at point P is positive 1/2. And hopefully all that makes sense. And you can tell it's 1/2. That makes sense because it's not increasing at such a steep rate. Like this one, the rate is -2. It makes sense that it's more steep than this one that has a slope of 1/2. So hopefully it's all kind of making sense to you. All right, so part F. Write an equation in point slope form of the line tangent to the circle at point P. Solve for y. Well, we already do that when we do point slope form. So remember, our point slope form is y equals m x minus x1 in parentheses plus y1. So we already have solve for y because that's the one we've been working with all year. So what do we need for point slope form? We need a point and we need a slope. So we want the equation of this line. Do we know a point on this line? Well, yes, we do. -2, 4. Do we know the slope of this line? Well, yes, we do. So then writing this equation should be very easy. Y equals 1/2 times the quantity x minus -2, so plus 2, close that quantity, plus y1, which is 4. Okay, got my equation of that line. I have to scoot up, sorry. Okay, so let R be the point where x equals 2 in the third quadrant. So remember, this is our third quadrant. Okay, determine the slope of OR. So let's get started with a couple of things first. Let R be the point where x equals -2. So I know I'm just going to come down here. This point has the same x value as point P. So we know it's just going to be directly below. All right, that tells us a bunch. So we know R is going to be, it's going to have the coordinates. We know the coordinates. We know the x value is -2 for sure, that was given. And how do we know the y value? Well, we know if you plug in -2 for x, just like we did here, we're going to get out the possibilities of y of +4 and -4. So in this case, what's our y value going to be? Oh yeah, -4. Okay, so we know the coordinates for r, but what it's asking for is the slope. How do we find the slope? Well, let's draw our little segment here. And let's think about our change in y over our change in x. Sorry, I have to keep going back and forth. Okay, so we fall 4, so that's -4 over, and then we go left 2. So we fall 4, we go left 2, so therefore that's going to be a +2. So our change in y over a change in x of OR is +2. So then determine the slope of the line tangent to the circle at point R. So that means we need to come over here and we need to draw the tangent line. I'm going to have to kind of turn my paper here so I can do my best job. So that looks about tangent. Remember, I've got to have a perpendicular line here. So I think that looks pretty good with my human eye. Okay, so I've drawn my tangent line at point R. And what I'm wanting is the slope of that line. So remember, since these two are perpendicular, here, let me write this in. This slope, remember we said this slope right here was 2. Let's pause for a minute. That slope was 2. Does that make sense? Heck yeah, it does. Positive slope and it's kind of steep. That makes sense. So then what's my slope of this perpendicular line to this line? It's m equals -1/2, right? Take the opposite reciprocal of that value. So my slope, change in y over change in x, equals -1/2 for that tangent line at point R. So then you guessed it, write the equation in point slope form of the tangent line to the circle at point R. So remember my point slope form, I have it up here. Do I have a point? Yes, I do. -2, -4. Okay, that point is on that line. Don't you agree? And then what's the slope of that line? It's -1/2. So therefore, I have all the pieces I need to write my equation in point slope form. So y equals -1/2 times this quantity x minus -2. So minus a negative becomes positive. And then plus y1, but my y1 is -4. So hopefully y'all are just hanging right along with me. Okay, part J, last part. Determine the intersection of the two tangent lines. Well, that's a cool question. Determine the intersection of the two tangent lines. How do I find that point, that ordered pair? What am I asking you to find? Do you remember this from Algebra 2 and even Algebra 1? Okay, these are two linear equations, and I'm asking you to find their intersection. How do you do that? Oh yeah, it's a system of equations. It's a system of equations where you want to find graphically where those two lines cross, right? Okay, so graphically, we can clearly see where those two lines cross. Okay, do I know exactly what that value is based on my graph? No way. It's not a precise graph. Could never be. I mean, unless I was a computer, right? Okay. Or if I had a coordinate grid in this case, because nothing is too terribly ugly, no decimals here that are terrible, so I could graph it on a coordinate grid. But do I want to take the time to do that? No. Algebraically, how do you find the intersection? You could use that thing called substitution. Remember that? Yeah. So since these are both in y equals form, you could just essentially set these two equations equal to each other. Okay, since they're both in y equals form, you could set these two equations equal to each other. So obviously I don't have enough space for this, so let's go to the back. All right, so on the back, take that first equation 1/2 times the quantity x plus 2 plus 4, okay, equals, right, okay, I copied it down right. And then this equation, negative 1/2 times the quantity it was x plus 2 minus 4. Hopefully you're remembering this. So since they are both in y equals, essentially you can set the equations equal to each other, solve for x. So let's do that. How do we want to tackle this problem? So do you want to distribute the 1/2 in and the negative 1/2 in here and work with fractions? It's fine with me if you do. Or do you want to go ahead and get rid of the fraction by multiplying both sides of the equation by 2? Okay, if you do that part, then you have to be really careful. So if you're going to distribute in, I think you'll be okay. All right, if you choose not to distribute in because you don't want to work with a fraction, then I assume what you're going to do is you're going to multiply this by 2 over 1, this side by 2 over 1, as well as this side by 2 over 1. But here's where you need to be careful. You need to be careful that you only distribute to this because this whole thing is a term. Okay, so you only distribute to this term once. This is a term because these are glued together, okay? And this is glued together with this parentheses. So you would only distribute here, and then you would distribute here to this second term. Same here, you would distribute here, and you would distribute here. So this would look like 2 times 1/2 would obviously be 1. So you don't have to write it if you don't want to, because there's an implied 1 right here. And then 2 times 4 is 8. Equals, and then here 2 times negative 1/2 would just be a negative 1 out in front. I don't write the 1 because it's implied. X plus 2, make sure you don't get rid of the parentheses because that negative still got to distribute into that parentheses, right? And then 2 times negative 4 is negative 8. And then of course the parentheses can fall off here because that positive 1 doesn't change anything. But here this would become negative x minus 2 minus 8. And then let's go ahead and add these up. And let's move this to the other side here. So this will become x plus x, right? When that negative x moves over, it becomes plus x. And then plus 10 equals negative 10. So really 2x plus 10 equals negative 10. So 2x equals negative 20. Are you following me? Okay, so divide by 2, so x equals negative 10. So am I finished? No, I found my x. How do I find my y? Okay, how do I find my y? Well, take one of the two equations. Does it matter which one? No, because they meet at that same point. So pick either of the two equations, doesn't matter which one, and plug in x. So I'm going to take just this equation, this one, the 1/2, where I see x, plug in negative 10 plus 2 plus 4. So y equals 1/2. Negative 10 plus 2 is negative 8. Okay, plus 4. And then half of negative 8 is negative 4. So negative 4 plus 0, plus 4, equals 0. That's interesting. Y equals 0. Does that make sense? It sure does. It makes perfect sense. I know I'm human and I didn't draw it perfectly, but it makes sense based on this graph and based on the slopes of these lines that these two lines would meet here on the x-axis. So that makes perfect sense. So real quick, over here what I was talking about, I just want to show this real quick. I know this video's already getting lengthy, but if some of you were wondering how you would do this the other way, how you would approach this the other way, what I was saying before. So if you distribute now, some of you might like that method better, to where you do 1/2 x plus 1 plus 4 equals negative 1/2 x minus 1 minus 4. So here you could either choose to work with the halves, or at this point you could go ahead and distribute 2 to every single term, and maybe that would make more sense to you to get rid of the parentheses first. So I just want to show you both methods. And you could even combine like terms here if you wanted to first, and then multiply both sides by 2 to clear out the fraction. If you have questions about that, then see me.